Hello, dear friends. Welcome to our webinar today. I'm David, the Technical Supervisor of High Target International. The topic today is the narration of for road in high survey roads. As you know, there is road in the name of the high survey road software. That indicates this software can be used in some road projects. Let's see how to do it. Firstly, I'm going to show you the elements we have in high survey road. And then I will explain how to design roads by high survey. And in the third part, I will show you the operation of importing Civil 3D XML file and staking out ligaments and offsets. Let's see some pictures of road in the real world. Is it beautiful? The roads have made our economy society more convenient and efficient. Now let's see what's the roads in high survey. There are a lot of terms about road design. Now in this page is a mess, but I'm going to make them clear in the next part. Okay, now you may be interested in how to design roads in high survey. Okay, let's see the second part. This is the main interface of high survey roads. Here you can see we support the center line. It means a ligament, and profile. It means vertical profile. Then the cross section and the side slope in high survey is side section. We also support construction design. The first is about a ligament. The ligament can show the shape of the road on the top view. Here is called also called center line in high survey roads. You can see the first picture is in a real world. In the second picture, you can see the yellow line. This is the ligament of the roads. And the third picture is a preview of the road in high survey. For this alignment, high survey road supports 3 methods to design the alignments. You can see the first one, we can support the intersection method, and then we support element method. Then we support the coordinate method. Later, I'm going to show you one by one. Firstly, let's to check the intersection point method. It's also named IP method. You can see this picture is a demo road. There is BP. The BP means the starting point. And you can see the IP, IP1, IP2. The IP means intersection point. Then you can see the TP. TP means the tangent point, which is between the straight line and the spiral curve. Here in this road, we have the straight lines, the spiral curve, and the arc, the circular curve. Then let's see how to import the parameters. You can see this table. We just need to input the name of the intersection point and the coordinate, the station. Then we need to input the radius of the circular curve. And then we need to input the length of the spiral in, length of spiral out. Later I will talk about it in detail. And the virtual point is only for some special projects in China now. So I'm not going to introduce this in today. Let's see how to input the parameters. In this demo road, the first step is to input the starting point. Here is the BP. For the starting point, we only need to input the lane, the northern eastern coordinate, and also the station of this starting point. Then the second step, we need to input the parameters of the intersection point. Here, we need to input the name, the coordinate, also the station of this intersection point here. After that, we need to input the length of this spiral curve here in the left side, this spiral curve. It names spiral in. And then input the radius of this circular curve here. After that, we input the spiral out, the length of spiral out here. You can see this part. After that, the parameters of this intersection point is finished. Then we input the parameters of the next intersection point. After we input all these parameters, then it is finished. And I'm going to introduce some new function in next version. You can see about this intersection point. For the current version, Hathaway Road, we only support to input the length of the spiral curve. You can see here. But in the next version, Hathaway Road 204, there is an option. We can choose to input the length, or we can choose to input the parameters of this spiral curve. Now we have a poll for you.
Okay, now time for poll. Please choose the best answer for the question so we can adjust the key points of presentation for you. Which parameter of spiral curve do you input when using IP method? Okay, let's check the result. 56% choose the second answer, curve parameter of spiral.
From the result of this poll, seems there is 50-50. Some customers is used to use the input the length. Some customer used to input the spiral parameters. Let's continue. Here is a video about the operation. Because I have explained the details of parameters in previous page, so in this video, I just import the PHI file, but you can see all the parameters. You can see the starting point, the information, the coordinate station, and also the intersection points, the coordinates, radius, and the parameters. After we input all these parameters, we can click the view to check the preview of this center line. We can click the apply and save the data. That's all about the intersection point method. And the second method is the element method. For the element method, the road lines are divided from complex combination to several separated elements. You can see in this picture, here are straight lines and spiral curve and circular curve. Let's see this table. In this table, we need to input the parameters. First, we need to input the starting point information, the station and the coordinates. And if it's needed, we can input the azimuth of this start point. And then we need to input we need to choose the type of the curve. We support 3 types of curves: the straight line, and arc, and spiral curve. For the straight line, we just input the length. And for the arc, we input the radius, length, and also we input the direction. For the spiral curve, we just input the radius, the length, and direction. You may see the start of that here. If the root lines is continuous, that means we just keep the start offset as 0. And start azimuth is optional. Okay, let's see how to input the parameters. There is also a demo road for the element method. You can see this is the starting point, and we just input the parameters of the road elements in the order from starting point to the end point. Let's do it. The first step, after we input the starting point, the next part is the straight line here. We just input the length of the straight line. Okay. Then the next part is spiral curve. For the spiral curve, you can see the start radius is checked as infinity automatically by the software. Because the spiral curve the radius of spiral curve changes from the infinity to this R1, the radius of this circular curve. So in this situation, the software will check this automatically. If in some special row design, the start radius is not infinity, we can uncheck it and input the value. Then we input the length of this spiral curve and choose the direction. In this line, the direction is right. Then next step is the circular curve here. So for the circular curve, we just input the radius of this curve and also the length of this curve. Then the direction is right. After that, we input all the parameters of these elements. After that, it is finished. Let's check the video here. In the center line, we choose the element method. Here, we can input the starting point information, and we can add the straight line or arc or spiral curve. Input the radius, length, all these parameters as I just explained. After we input all these parameters, we can click the view to get a preview about the center line here. Okay, after that, we apply and save this data. That's all about the element method. And the third method is coordinate method. Because in some situations, you can see in this picture, in some situations, maybe the straight line is not tangent with the circular curve here. And also if in some special design, the straight line is not smooth. And if there is any offset, so we need to use the coordinate method. Then let's see the parameters we need to input. In this table, for the coordinate method is a little easier because we just only need to input the coordinate of the endpoint. The first, we need to input the starting point, input the station and the coordinate of the starting point. After that, we choose the different line. Now HiSurvey only supports the straight line and the circular curve, only two types. Then we choose the line type and input the coordinate of this endpoint here. After that, we add another curve, the circular curve. We can input the end points for the arc. We also need to input the radius and also the direction. Okay, let's see the demo road. Here in the demo road, there is a starting point, and the first part is straight line, and there is an intersection point A. Then there's the circular curve. After that, there is a point B, then the straight line. So we need to input the parameters of all these elements in the order from starting point to the end point. The first step is about the starting point. For the starting point, we just input the station and coordinate. Next step, we just input the coordinate of this endpoint for this straight line. The endpoint is point A. And the third step, we need to input the coordinates of the endpoints of this circular curve. The endpoint is point B. We also need to input the radius of this circular curve and the direction. The direction should be right. After we input all the parameters, it is finished. Then we can have a look about this video. We click the center line and choose the coordinate methods. We click start to input the parameters about the starting point. And then we can choose the straight line or circular curve. Here we just input the coordinate of the endpoint. You can see. And after we input all these parameters, let's see the preview. Here, click view. This is a preview about the road we just inputted. And we can also check the details. After that, we can apply and save this data. Okay, this is all for the coordinate method. Now it's poll time again.
Which method of designing road do you usually use? Intersection method, elements methods? I am not so clear. Okay, time's up. Let's check the result. About 46% choose elements method.
Okay, from the result of the poll, seems lots of customers prefer to use the element method. Then let's continue. The next part is about the vertical profile. Let's see the picture. The vertical profile. You can see in the first picture is there are two straight lines with different gradients. So between these two straight lines, there should be a curve to make the car drive more stable. And the picture in the right is a preview of the vertical profile in Highway Road. Here we also have some parameters about the vertical profile. Okay, let's see how to import the parameters about the vertical profile. Highway Road only supports the circular curve between the two straight lines. For this curve, we only support circular curve now. So if you need more curves, then you can give us some feedback. Maybe we can do support some request in the future to support more different type curves. Let's see how to input the parameters. You can see the first picture here. There is PVI. The PVI I'll call it is PVI. PVI is the point of vertical intersection here. The intersection of the two straight lines, these two straight lines. And this is the next PVI. And this curve is a circular curve, so there is a radius. And the picture in the right is about high survey. In high survey, the name is snow point data. That means it is for the PVI, the point of vertical intersection. For this, we just only need to input the station of the PVI here and input the height of the PVI and the radius of this circular curve. Okay, let's see the operation video about this part. Here we click the profile. The profile means the vertical profile in Hathaway Road. Now we can add some data about the PVI. First, the station, and then the height of this PVI. Then input the radius if it is needed. Then the next PVI, station, height, and radius. You can see. After we input all the parameters of this PVI point, let's see the preview here. We can click the view to check the preview about the road we just designed. And we can click here to check the details. In this interface, there is a function to check station. You can see here, we can input the station. If we input 40, the software will calculate the height on the 40 station. Okay, like what you see. And now there is another pole.
Okay, which type of vertical curves do you usually use? Circle curves, parabola, others, and I am not so clear. Okay, thanks for your answers. Let's check the result. About 50% choose the circle curves.
Customers use the parabola and others. So if you need another curves, you can give us feedback. Maybe we can support it in the next versions. Okay, let's continue. After the vertical profile, the next part is cross section. And let's see the cross section. There is a picture. You can see this is the center line, and in different station we can get the cross section. And in this picture, we can see some information such as the roadway. Here is a roadway and sidewalk and green belts. And we can also see the gradients here. You can see the gradients and also the width of each lanes. And this picture is the preview in Highway Road. Here we can also check the different lanes here. This is the first lane, and this is green belt. Also, we can see the width, 10 meters, and the gradients we can see here. Okay, let's see about the parameters we need to input. For the cross section, we need to input first we need to input the lane, such as the roadway or sidewalk. Then we need to input the gradient. In Highway, it is named grade. Here, this is the standard cross section. You can see here, the center of this point is the highest, and the height of the outer edge is lower here. After that, we also support to input the curb. You can see there is a curb between the roadway and the sidewalk. If it is needed, we can input a curb. And then we also support the construction height. This means the thickness between the road surface and the subgrade. But this is optional. If it's not needed, we just keep it empty. But then let's see the video about the operation here. Here we input the cross, we click the cross section here, and in the standard, this is for standard cross section, we add the cross section and input the lane, the gradients input, and you can see. Then the next part, maybe this is a sidewalk here, and input the gradient, the width, 2 meters. The curb, if it's needed, we can input. Maybe this is. Now you can see here, this is a curve we just input. Then the next part, maybe it's green belt. We can input the parameters, and you can see. Then continue. We input all the parameters one by one. Here you can see there is a choice named left-right identity. That means if I check this, we can make a copy from the left side to the right side, so we don't need to input again. And we can click the details here. We can check. Okay, this is all about the standard cross sections. Now maybe you have some questions. If in some special design, we can the cross section, the standard cross section is not enough. We need some other special design. I just talk about if in some special design, what we should do. We have two types of different cross section. The first one is super elevation. You can see this picture. In some situations, if there is a turn, you can see in order to protect the car, so we need to raise the outer edge here. You can see. You can see the right picture. There is S1, S2, S3. You can see the S1 is the standard cross section. At the S2, you can see the outer edge is the highest. Then there is gradients here. So this is a super elevation. Then how to input the super elevation in Hathaway? Then let's check this table. For this situation, we need to input the parameters of the changing points here. What I mean, the changing point, that means the S1, you can see this is S1. Before the point S1, the cross section is standard. And after the point S1, it is super elevation. You can see. Then another point is S2 here. That means from S2 to S3, there is also the super elevation. And then the S4, in this point, it comes to the standard cross section. So let's check how to input. We need to input all these parameters of the changing points. For the S1, we just input the station here, 20 meters station, and the gradient. You can see this is the standard one, so the gradient is minus here. Then the next one, we input the S2. The station is, for example, is 30 meters, and then the gradients. In order to have a better result, so we just input 20% grade. Later, you can see the result. And continue the parameters of S3 here. Input the station, grade, and then the S4, the station and gradients. You can see the gradients come to normal. This one. For the gradual in Hathaway Road here, we just, it means the type of the line from the S1 to S2 here. We support the straight line and cubic parabola. Then let's see the operation video about this super elevation. Before we add the super elevation data, we need the standard cross section data. You can see there is standard cross-section data. After that, we can add some information about the super elevation here. You can see the station 20 and 30. This is the gradient. You can see after we input all these parameters, let's see the result here. Here, in this preview interface, we have the function to check the station. Then we can see the result here. We can input the station, for example, 20 meters. This is normal. You can see the gradient is normal. And on this, the 30 and the 40, this is a super elevation. You can see the difference here. This is the difference. And the 50, it comes to normal again. After that, we can apply the data and save. So this is the operation about super elevation. Then the second special design is named curve widening. You can see the first picture. Because in some place of the road, if there is another construction, or maybe if there is a bus station, you can see here. So the width of this lane should be widened. You can see here the width is widened, and you can also see the right picture. This is what we can see in Highway Road. In this area, you can see the width is widened. Then let's see how to import the parameters in this table. Let's see what we need to input is the station and the width and the gradual. That's all. Let's check one by one. There is a demo road here for the curve widening. You can see there is a point W1. In this point, in this point is standard cross section. After that, the cross section was widened here. You can see, and from W2 to W3, you can see the lane is widened, and in W4 it comes to normal. Let's check the right picture. So for this situation, we need to input the parameters about all these 4 points. That means the changing point, like the super elevation. For this one, the first one is W1. Here, we input the station of this W1 here, maybe it's 20 meters here. And then the width here, in Hathaway it's show wide, but the width now is 4.5 meters. This is the standard. Then we need to input the W2. For the W2, we input the station, and we need to re-input the width. So you can see the value is 20 meters. That means we just input this value to replace the original value of the cross section. The original value is this one, 4.5, but here we just input a new value. That means the value of this red line, you can see this red line, is the new width. Here we just input the 20 meters. Then let's continue. W3 is similar with W2. We input these parameters, and then for the last point is the W4. We also need to input the station and the width. You can see in the W4, the width come to normal is 4.5 meters here. Okay, then you can see this operation video about what I just said. Before that, we also need the standard cross-section data here. This is the standard. Okay, then we click the wide plus, means the curve widening in highway roads. Now we input the parameters one by one. You can see just like what I said. Okay, after we input all these parameters, we can check the result here. And in this interface, we also support check station. Here, we can input the station, then we check the cross section. Now this is normal. And in 30, you can see here, this lane is widened here. So the width come to 20 meters. And then in the 50, it comes to normal again. We can also check the preview in the stake road interface. You can check here. This is in staking road interface here. You can see it was widened in this part. Okay, that's all about the course section. Okay, the next part is about side slope. Let's check the side slope. You can see the first picture here. In the red box is about the slopes. And this is the roadway we just introduced. And now we are going to introduce the parts out of the roadway here. You can see there is a hinge point. That means the point between the roadway and the side slope. In some construction work, this is very important. You can see we have two different situations. The first one is named field slope. Here you can see this picture. In this picture, you can see the designed line is above the original ground. This is original ground, and this is design line. So we need to fill the construction materials to up to this level. Then the next type is named cut slope. That means the designed road is under the original ground. Here, this is original ground. The designed road is under the ground. So we need to dig out the soil to get the designed line. Okay, let's see how to import the parameters in HiSurvey. For the field slope, you can see this demo data. This one, you can see the green line. The green line is roadway, and then there is a hinge point. Then there is a side slope. So what we need to do is input the parameters of this slope in the order from hinge point to outside. Let's see. The first part, you can see the first part is the slope here. And for this slope, what we need to input is the slope plane and slope height, then the gradient. For these parts, the format of this gradient is like 1 to n. Then we input the value of n. Here, this is 1 to 1, so this value should be 1. After that, the next step is about this stage here, this stage. For this stage, we need to input the name and the width of this stage here. Here, the width is 3 meters. And also we need to input the gradients, the gradient about this stage here. But in this place, the format is different. The format is the percentage. After that, we input the next part. The next part is a ditch. You can see in some construction work, there may be some water in this ditch. For this ditch, we only support two types. One is the rectangle, and another is trapezoid. This one is trapezoid. This one. So for this trapezoid, we input the width of the top here is 3 meters. Then the width of the bottom 2 meters, and also we need to input the height of this ditch here. After we input all these parameters, then let's see the result. You can see the first picture, we can check the offset from hinge points. You can see the offset of each part. And the next picture here, we can see the preview of the side slope we just designed here. Oh, that's about the field slope. And how about the cut slope here? It's very similar. Everything is the same. You can see the green one is the roadway, and what we need to do is to input the parameters in the order from hinge point to outside. You can see the first part is a ditch. For this ditch, it's a rectangle here. So we input the name and input the width. So you can see the top width and the bottom width is the same. We also need to input the height here, 1 meter. After that, the stage is very similar. We input the name, the width, the gradient. Then next step, you can see this is the slope. Then we input the parameters of this slope. After that, this is the result. You can see. Okay, then let's see the operation video about the side slope, how to combine this side slope with our cross section in highway road. In this road design, we input the parameters in the side sections, means side slopes. We create the field slope. This one is for field slope. You can see after we input the parameters, you can see. Then next one is the cut slope. Let's see, we input the parameters for each factors one by one. Then continue. This slope. Okay, after that, you can see this is a preview. And we can click apply and save the data. After that, we come to the staking rail interface. Let's see, staking rail interface. And choose the road line here. This is the top view. We can click this icon to switch to a cross-section view. Here, we can see the view. And in the bottom, we can choose the side slopes we just added. Here we can choose the direction. In this video, it's in the right side, so we choose the right direction. Here you can see this is the field slope, and when we're sticking out, we can, if in another station, maybe we can use another slope. For example, this is cut slope. We can combine this slope with the cross section. And we also can see the position of RTK here. The red dot is RTK. Okay, that's all about the side slopes. Then the next part is about construction design. As you know, there is some covers under the road, or there is some footbridges over the road. So in highway road, we can support to input the construction. Here you can see the first picture. There is the construction type. We have 4 types of construction: the covered and passageway, and circular covered and footbridges. But don't worry, the highway roads, these 4 types of construction will be abstracted to one mode. Here you can see this picture. This is the only one mode for the 4 types of constructions. All the parameters we need to input are the same. But for this mode, we have the straight one and the slanting one. The straight one means the X of this construction is perpendicular with the road. You can see. Okay, then let's see how to input the parameters. The left picture is all the parameters about the construction, and the right picture is what we need to input in highway road. Let's see, the first one is the station. That means this construction is established on the station here. The second one is what I just said. I think this is a text. This is a text. We just choose different types, but all the parameters are the same. For this one, we choose the slanting here. For the parameters, we need to input the angle. The angle means the angle between the X and the road. Here, you can see in this picture. This is the angle we need to input. And then the front width and back width, left width and right width. Let's see the picture in the left side here. There are blue lines you can see, and there is also a point C here. The point C means the intersection of the X and the road. And the blue line, you can see this blue line. The blue line is perpendicular with the edge of this construction here. So you can see there is front width, back width, and left width and right width. We just input this 4 width to the highway road here. After that, we also need to input the center height. The center height means the height of this point C. You can see the point C, the height of this. At last, we need to input the gradients. Gradients, direction of this gradients is like this arrow. You can see This is in this arrow, the profile slope. Okay, after we input all these parameters, let's see the operation video about this construction design here. We click the construction design and we input the station, for example, this 100 meters, and choose the text. For this, I use the slanting. Then input the angle. This I use 60 degree, and the width. Let's see, I input the width one by one, and the center height, and also the slope. After I input all these parameters, I click OK. Then we can check the preview. Here we click the view, and we can also click the details. Then you can see all the parameters about this construction here. Okay, that's all about the construction design. Okay, let's continue. Then there is the third part. The third part is about the operation of staking roads. Before this part, there is a poll for you.
Okay, have you imported the Civil 3D XML row file to Highsurvey Road? Yes, I have. No, I don't know Highsurvey Road supports it. No, I don't use row function in Highsurvey Road. Okay, time's up. And about 60% choose yes, I have.
Okay, from the results, it shows a lot of customers have used the land XML file in Highsurvey Road. That's a good news. Now I'm going to introduce this one. If you have a land XM file from Civil 3D, that's a good news, and it will be easier because what I just said before, the design operation is a little complicated. So if you have the XML file, it will be much better. Okay, let's see how to operation. The first step, you can see in Highsurvey Road, we click the road design and import the XML file. Then we choose the file. And after that, we can see we can see all the attributes in this XML file. Maybe there are some ligaments and the vertical profile and cross section and others. You can see if there is a check. If there is no, there is a cross. Then the next step, we need to go to the stake road interface here and choose the road line. We just import it. Then we can see this interface. There is a top view about the road. After that, we can click this icon for staking out the road. After we click, you can see there is a station and offset. For the station, that means we just staking out the center line of the road. For the offset, that means we stake out the offsets from the center line. Let's see. How about the staking out center line? Here in this interface, we can input the station. Here you can see is a milestone. This is the station of the road. We can input, and there is also step. Step means the increment value of the station. If we click the next point, we can stake out the next points with this increment. You can see this is the interface about staking out. After we click this icon here, you can see we just input the station as 5 meter and step as 5 meter. And you can see there is a next icon here in the central picture. Here is an icon. If we click this icon, the station will be 10. Then if we click again, it will be 15 here. Then we can stake out on the next station. You can see this is about the center line. And then let's see the offsets of staking out. In this interface, we just input the offset. Here you can see it's 1 meter and step is 1 meter. That means if this is the first point, you can see the offset is 1 meter. After we click this next icon, the value will be 2. The offset will be 2 meters. Here you can see. And let's see the next one. This is offset on 3 meters. Offset on 4 meters. You can see the difference here. Okay, let's see the video about this staking out. You can see in road design, we import the XML file. You can see all these attributes which this XML file has. Then we go to the stake road interface, which is this line. Now you can see this is the interface of staking out. And there is also an icon here. We can click to switch the view from the top view to cross-section view. This is a cross-section view. And click the staking out. Here we input the station. Now you can see after I input this station, you can see there is the difference in the bottom here. Shows in this red box, it shows the difference from the current point to the destination point. We need to go forward and we need to go left. And also there is the difference in the elevation. You can see now I'm going to the destination point. You can see I'm walking, and then I'm in the destination point. And here, this is next point. You can see the station is 6 meters. After we staking out this point, we can click next here. Now this is for the offset staking out. Here we input 1 meter and step 1. Now you can see this is the destination here. Then we're going to this point here. You can see. Then if I click this next icon, we can staking out the next point. You can also see this cross-section view. There is a red dot. This is the GNSS receiver, the position of the GNSS receiver. You can see this is the next point. We click the next, then this is the next point. This is the information about what we need to move. And in this cross-section view, you can see there is a distance, and also there is the cut value. That means the difference from the GNSS receiver to the designed level. That means cut or fill. Okay. So this is all about the staking out. Okay. If you have any questions, you can send emails to these addresses. And then thanks a lot for you to attend in today's topic. Thank you a lot.